Seventh graders, we're going to get ready for a test tomorrow by going through Study Guide 1. Before you watch this video, make sure your study guide is complete. As you are watching this video, you're not only correcting your problems, but if you get the problems wrong, you're going to want to fix them, show the right work, and make sure you understand how to do them, because again, your test will be tomorrow. I have a couple things with me. I do have a calculator ready to go, and then I have my note card. Now, I didn't have a note card at home, so I did just use a piece of loose leaf with all the different formulas I thought were going to be helpful when I'm completing this test. I will also link this on Google Classroom. All right, 9.1. I can find and approximate square roots of numbers. Find the square root of a number. When you take the square root of a number, remember, there can be two answers. 10 times 10 is 100, and negative 10 times negative 10 is also 100. So you're going to have two answers, a positive and a negative answer. You can list them with a plus or minus, or you can list 10, comma, negative 10. Same with 36. When you take the square root of 36, you're going to get two answers, a positive 6 and a negative 6. If you don't put that plus or minus, or if you don't put your two answers, you will get a point taken off. Number 3, approximate the square root to the nearest integer. Students get this section wrong, these two wrong, because they don't estimate. They put this into the calculator. That is not what they're asking. They want you to estimate. So this is where you think of perfect squares that surround 50. I'm thinking of 49 and 64. Whatever perfect square is closer to this number is the one you take the square root of. And then that's your answer. This one does not have two answers like the first two problems, because out front here, there's a positive, so they want the positive answer here. The same with this one right here. I'm thinking of perfect squares that surround 12, 9, and 16. Whichever one's closer, you're going to take the square root of. Because this is negative, my answer is negative. 9.2, I can simplify radical expressions. Same as above, some people just turn into a robot and just put this right into their calculator. That's not what they're asking. They're not asking for a decimal answer. They're asking for you to simplify. So I'm going to think of different factors of 80, and when I simplify, I want to find the largest perfect square of the factors of 80. So let me show you. 1 in 80. 2 times 40, 3 does not go into 80, 4 goes in 20 times, 5 goes in 16 times, 6 does not go in, 7 does not go in, 8 goes in 10 times. 9 doesn't go in. I can stop because I meet this 10. There's a bunch of factors. I'm looking for the set of factors that have the largest square root, the largest perfect square. So nope. This is a perfect square. This is a perfect square. Nope. 16 is the largest perfect square, so I'm going to separate 80 into 5 and 16. Take the square root if you can. The square root of 16 is 4. 5, we cannot take the square root because it's not a perfect square. So this is my answer because there are no more factors in this number. No more factors that are perfect squares. When you have a fraction under the radical, you're going to want to separate the numerator from the denominator. And it happens that both of these are perfect squares, so I'm going to simplify the numerator and simplify the denominator. 9.3, I can use the Pythagorean theorem to solve problems. Find the unknown length, show your work. So if I weren't sure what the Pythagorean theorem is, I would look at my note card here. I see that it's a squared plus b squared equals c squared. Remember that your a and your b will always be the legs, and your c will be the hypotenuse. So instead of a, I'm going to write 12 squared plus b squared equals c squared, which is 20. 12 times 12 is 144, and 20 times 20 is 400. This is an equation where I want to get b by itself, so I'm going to subtract the 144. This is not by itself yet because it has a squared. The opposite of a squared is a square root, Whatever I do to one side, I do to the other. The square root of 256, I could put right into my calculator to get 16. Your legs will always be A and B, and your hypotenuse is C. So A squared plus B squared equals C squared. 16 times 16 is 256. 30 times 30 is 900. This one's different than the last problem because both of these terms are on the same side of the equal sign, so I'm going to add them up. Take the square root, put that right into my calculator to get 34. Determine whether the triangles with the given side lengths is a right triangle. I don't have to draw anything. This is actually the Pythagorean theorem. It's still under the 9.3 Pythagorean theorem section. And I'm going to put this right in order into the Pythagorean theorem. 4 squared plus 5 squared equals 6 squared. And I'm checking to see if both sides are equal. So 16 and 25, does that equal 36? 16 plus 25 is 41. Because these are not equal, your answer is no. These are not three side lengths that create a right triangle. .4, I can compare and order real numbers. Tell whether the number is rational or irrational. Rational numbers are decimals that terminate, which means stop, or repeat. So if I'm not sure what kind of decimal 2/3 is, I'm going to take my calculator and I'm going to do 2 divided by 3. And I see it's 0.6 repeating. I know that the last digit is a 7. My calculator rounded. This is going to go on forever. That's a rational number. Again, rational numbers are numbers that go on forever without stopping. Rational numbers are numbers that terminate or repeat. Irrational numbers are numbers that go on forever without repeating, like the square root of 5. This number is going to go on forever, and there's no repeating pattern here, so it's irrational. Complete the statement using less than, greater than, or equal to. It's hard to compare when you have different forms of numbers. I'm going to turn these both into decimals. So I'm just going to round to the hundredths place, 2.65. And then you could turn that into a mixed number, or you could divide it right out. 2.67. So 8/3 is larger. Use that same process when you're ordering from least to greatest. This is a decimal, so I'm going to find the square root of 10. And maybe I round to the hundredths this time. 7 divided by 3. It doesn't matter really where you round, as long as you can compare at the end. The square root of 4 is 2. They want least to greatest, so the smallest number is 2. Put the originals down. Don't put the decimals down. 2.3 is next. 2.9 and 3.2. 9.5, I can use the distance, midpoint, and slope formulas. Find the distance between the points, write your answer in simplest form. We're going to cross that out, and you're going to write your answer rounded to the nearest tenth if necessary. It's not going to be necessary for this one. If you don't remember what the distance formula is, you're going to look at your note card or in your notes. Here's the distance formula, so I'm going to plug the information right into that formula. I'm going to write this here so I can see it. This is my first ordered pair, so it gets subscripts of 1. This is my second ordered pair, so it gets subscripts of 2. Plug it right in. Follow the formula. The second x minus the first x. The second y minus the first y. Excuse me. The second y minus the first y. That whole thing is going to have a square root or a radical over it. Here I have 4 squared. Here I have 3 squared. 4 times 4 is 16. 3 times 3 is 9. The square root of 25 is 5. The distance between those two ordered pairs is 5 units. Number 15, I'm finding the midpoint. The midpoint formula looks like this. It is an ordered pair. They don't give me ordered pairs here. They just give me a line, so I'm going to have to go down to the picture. A is -4, -4. B is -3, 0. This is my first ordered pair. This is my second ordered pair. I'm going to follow the formula. The first x plus the second x. The first y plus the second y. So here I get -7/2 and -4/2. You can leave this a fraction, you can turn it into a decimal, you could turn it into a mixed number. I'm going to turn it into a mixed number. And the second one I can divide out. So -3.5, -2 is the answer. We're not doing 16, we're going to save slope for another day. 9.6, I can use special right triangles to solve problems. Find the unknown lengths, write your answer in simplest form. So special right triangles were your shortcuts. I would definitely have those shortcuts written down. There are two shortcuts. There's a 45-45-90 and a 30-60-90 triangle. I see that number 17 is a 45-45-90. We know in that type of triangle that the legs are the same and the hypotenuse you multiply times the square root of 2. So I'm going to identify that these are the legs because they're next to the right triangle, and I'm going to identify that this is the hypotenuse because it's across from the right triangle or it's the longest leg. We know that the legs are the same, so x is 12. To get from a leg to a hypotenuse, we multiply times the square root of 2. So if the leg is 12, the hypotenuse is 12 times the square root of 2. That's as far as you have to go. This is a 30-60-90. That's this triangle. This is a leg. This is the long leg. This is the hypotenuse. So I see they give us the short leg. We want to go from short leg to long leg. Short leg to long leg, you multiply by the square root of 3. Again, I'm going to use that short leg. To go from the short leg to the hypotenuse, you multiply by 2. Short leg to hypotenuse, you multiply by 2. 9.7 and 9.8, I can use tangent, sine, and cosine to find the side lengths of right triangles. Find the value of x, round to the nearest tenth. This is sine, I guess I don't need a comma, cosine, so soca, toa, tangent. The triangle's going to tell you which ratio to use. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So this first triangle here, I'm working with 20. I have an opposite and an adjacent. Opposite adjacent is tangent. Opposite adjacent. So I'm going to plug that in. Round to 4 decimal places. And then solve for x. I'm not even going to clear it out of my calculator. I'm just going to multiply by 48. And round to the nearest tenth. This is 17.47, so 17.5. Number 20, I'm working with 40 degrees. I see they give me an opposite and a hypotenuse, so this time I'm using sine. Opposite over hypotenuse. So the sine of 40 is 0.6428. Multiply that by 15. Oh, that's a y, not an x. Round to the nearest tenth. Last problem. This time they give me adjacent hypotenuse, that's cosine. Adjacent hypotenuse. The cosine of 65, 0.4226 equals z over 8. Multiply both sides by 8. And round to the nearest tenth. 3.38 is 3.4. 4. Okay, now when you take your test tomorrow, we have one more, I'm sorry. A ramp that is 10 meters long makes an angle of 21 degrees with the ground. What is the height h of the ramp? Round your answer to the nearest tenth. So this is still SOHCAHTOA. This angle tells me that we're using opposite hypotenuse. Opposite hypotenuse is sine. Opposite over hypotenuse. The sine of 21. 0.3584, and then multiplying that by 10, 3.58 or 3.6. So the height of the ramp is 3.6 meters. Okay, so when you're doing your test tomorrow, make sure you have all your supplies. You have your calculator, you have your note card with your formulas, and there was also a golden sheet that you were given with perfect squares and square roots on it that you're going to be allowed to use.